Okay, so our notes on asymptotes. So asymptotes are lines that a graph approaches and gets closer and closer to. But does not cross. I'm going to put in math 3. So everything we're going to do in this class are asymptotes. They won't end up crossing. I want to point out, if you go to pre-calculus and calculus and beyond, there are some cases where you cross an asymptote and it still is an asymptote, but for everything we're going to do in this class, it'll get closer and closer to that line, but it won't actually cross it. So y equals 1 over x and y equals ab to the x. Those both have asymptotes. So 1 over x, we looked at that yesterday, and that could have like something else in the denominator with it, x plus 5. I think you had one in your homework last night that was 2 over x. So anything of this form is going to be kind of those two pieces that we saw yesterday, and then y equals ab to the x, hopefully we remember from math 1, which is going to be your exponential equation. All right, so we'll go ahead and do an example. So y equals 1 over x plus 4 and then minus 2. That's x plus 4 in the denominator if it's hard to read it. So we're just going to graph this so you can kind of see what it looks like and we can identify the asymptotes. So for this graph, this is a little bit different than yesterday. Yesterday, we just had something like 1 over x plus 4. If I ignore that minus 2 on the outside or after it. So 1 over x plus 4, hopefully we remember from yesterday, that kind of moves our graph left 4. And then adding a minus 2 at the end, just like with parabolas, this is going to move it down 2. And I don't expect you to necessarily have this memorized. Hopefully you understand this part, that the asymptote is at -4. So 1, 2, 3, 4. So remember, 1 over x, that has asymptotes at both of the axes. So if I move it left 4, this asymptote went left 4, and down 2, this will be my horizontal asymptote at y equals -2. So this line is y equals -2, and this line is x equals -4. And I'll just sketch the graph from there. So remember, it's going to have these two pieces. that curve, it gets closer and closer to this asymptote. And that graph will look something like that. Okay, so on problem 16, it says Junior is saving money in his piggy bank. He starts with 10 cents and adds 2 pennies each day. Complete a table, draw a complete graph and write an equation to model this situation. So since it's a model, it's going to end up just being linear. If it was asking you to show a graph over time with how much money he had each day without a model, but since it's going up at a constant rate, you're just going to model it with a y equals mx plus b equation. So hopefully that answers that question. Okay, so on problem 36, it says George was solving the equation 2x minus 1 times x plus 3 equals 4, and he got the solutions x equals 1/2 and x equals -3. Jeffrey came along and said, you made a mistake. You set each factor equal to 0, but it's not equal to 0, it's equal to 4. So you have to set each factor equal to 4 and then solve. Who's correct? Show George and Jeffrey how to solve this equation, and to be sure that you're correct, check your solutions. So what's going on in this problem is, sorry, I'm trying to minimize those. George tried to use the zero product property, something times something equals 0. So one of them 0, except it's not equal to 0. So Jeffrey comes along and he says, okay, well, since we have two things that have a product of 4, you have to set them equal to 4. The reason that's not correct is because there are lots of things that we can multiply together to give us 4. It could be 1 and 4, 2 and 2, 1/2 and 8. The possibilities are endless there. Whereas with 0, you know one of them has to be 0. So what you're going to do to solve this problem so it's 2x minus 1 times x plus 3 equals 4, is you have to get it equal to 0, and then you can use one of the processes that we used yesterday for solving quadratic equations. So in order to get it equal to 0, we'd have to subtract the 4, but before we do that, we need to multiply this left side out. So 2x minus 1 and x plus 3. So we have 2x squared plus 5x minus 3 equals 4. So then if I subtract 4 on both sides, and add 2x squared plus 5x minus 7 equals 0. And now you can use one of those 3 methods from yesterday. You can try to factor it. I believe this is factorable. You can complete the square. This one's tricky though because our a value isn't 1. And we didn't review that yesterday. Or you can use the quadratic formula. But then remember, once you get your answers, you have to, so you're going to solve this. You're going to get x equals something and x equals something. and then you're going to check your answers to finish this problem. So plug them in one at a time, and then make sure you get 4 on this left side. It says Jill needs to cut a smaller piece from a 30-foot length of lumber. Create multiple representations, a table, graph, and equation for the function with x values that are the length of the piece Jill cuts off, and the y values are the length that is left over. Which representation best portrays this situation? So again, she has 30 feet and she needs to cut off a smaller piece, and x is the size of the piece that she cuts off. So and then I guess I should have wrote length. Let me share that other screen. So that was given to us in the directions. X is the size cut off or the length cut off, and Y is the length left over. So if she cuts off 10 feet, then she has 20 feet left because it was 30 feet long. So our equation here is going to be 30 minus X. Again, so if you think about a table, and maybe I should have done that before the equation. If I don't cut anything off, I have 30 feet left. If I cut 1 foot off, I have 29 feet left. If I cut off 7 feet, I have 23 left. If I cut off 18, I have 12 left. So to get how much is left, you subtract how much you cut off from 30. So there's a table, there's our equation, and then you would want to graph it. For your graph, you only need a 1 quadrant graph because you can't have negative values cut off or left over.